Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 1 Learning Target 6. Today we're talking about graphing lines. So when we are graphing linear equations, the first thing that we want to check for is to make sure that the equation is in slope-intercept form. That is a must. We need to have y by itself in the equation in order to put it on a coordinate plane. So that is our first step, is to convert all of our equations into slope-intercept form, and then we would put them on a graph from there. So let's just take a look at some examples. In number 1, I see that I have the equation y equals negative 2/3 x plus 3. So when I am graphing these things, I want to remind myself that the 3 is the y-intercept, and that the negative 2/3 is my slope. So this is already in slope-intercept form because I can see that y is by itself. So that's a check, okay? So 3 is my y-intercept and negative 2/3 is my slope. The reason I point out the y-intercept first is because that's the first point you're going to put on your coordinate plane. You're going to go ahead and graph that y-intercept first. The y-intercept being positive 3 means I start at the 0, 0, and I count up 1, 2, 3 places. The y-intercept is where x is equal to 0, and then the y value is equal to whatever that value is. So in this case, it's 0, 3. So I'm on the y-axis, meaning I haven't moved left or right at all, and I go up 3 places and put a point. Okay, now from that point, the slope, that I would calculate the slope next, or I would graph the slope next, I should say. From that point, I want to graph the slope next. That slope is negative 2/3. That means I'm going to drop down 2 places and go right 1, 2, 3 places and put a point, okay? In case you forgot, slope is also technically rise over run. So that negative means that I'm going down 2, but I always move to the right. This negative out front tells me I want to move down, but then I am always moving my line over to the right, okay? So let's keep going. I was at this point. I'm going to do it again. Go down 2 places and write 1, 2, 3 and put a point. You can also go the reverse. You can do the opposite direction. You could go up 2 places and left 1, 2, 3 to count backwards and fill in more points on that line. And then always, 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 you want to connect your points with a line. A lot of people just graph the points and then leave it, but that's not actually what you're graphing. You're not just graphing a few coordinates, you're graphing an entire line that continues on in both directions. So you want to make sure that you connect those points together. All right, let's take a look at number 2. In number 2, I have y plus 4 is equal to 1/2 times x minus 4. The first thing I recognize is that this is not in slope-intercept form, so I have to take care of that part first. So I'm going to distribute this 1/2. It's going to go to both of those. That gives me y, let me change to a color you can see a little better. Y plus 4 is equal to 1/2 x, and then half of 4 is 2, so minus 2. Okay, then the next thing I would do is subtract the 4. The 4 is a constant, so it's going to come over to the very end where that negative 2 is and line up with the negative 2. That cancels that, and that leaves me with y equals 1/2 x minus 6. I did have minus 2, then I went down 4 more. So now I have minus 6. All right, that's my equation. I want to go ahead and graph this now that I've got y by itself. Check, I'm good. My y-intercept is negative 6. And then my slope is positive 1/2. Okay, that's our slope. So I'm going to put that y-intercept on the graph first. That y-intercept is negative 6, so I'm starting at 0, 0, and I come all the way down to the negative 6 and put a point. Then the slope is positive 1/2, so that means I'm counting up 1 and right 2. Up 1, right 2, and again, that's just rise over run. I rise 1, I run 2. There's 4 points. It doesn't really matter how many points you make, but what you do want to make sure of is that your line spans the entire coordinate plane. So like you'll see in my example in number 1, see how I went all the way to either side of the coordinate plane? That's what you want to make sure you have. All right, let's take a look at number 3. Now, in number 3, I have 2 points. So I'm going to graph a linear equation that gives me those 2 points. the first thing that I want to do, I'm going to take those, since I have 2 points, I'm going to go ahead and take those 2 points and I'm going to put those 2 points on my coordinate plane. So from 0, 0, which is in the middle, I want to go left 1 and up 1, 2, 3. My x was -1, my y was +3. Okay, I'm kind of going to work backwards in this one a little bit because I'm going to start with 2 points and I'm going to write the equation from there. So I'm kind of going a little bit backwards. All right, so then I'm also going to graph the other point, 5, -3. So I go over to 1, 2, 3, 4, 5, and down 1, 2, 3, and there's my other point. Okay, so now we're just going to go ahead and we're going to connect those 2 points with a line, and that is our linear equation. Now, from there, I could take the time to actually figure out what the equation is. If you were asked that on a multiple choice test, you could go through the hassle of finding the slope and you could find the y-intercept and you could go from there. In this case, it looks like my slope is, if I do rise over run, I go from this point to this point. I would go down 1, 2, 3, 4, 5, looks like one more, 6, that's -6. And then I'd run 1, 2, 3, 4, 5, +6. So my slope is -6 over +6, which is really just -1. The other thing you could point out on this, the other piece that you need is that y-intercept. And the y-intercept looks to be +2. I should put y-intercept, sorry. The y-intercept is +2. So if that's my y-intercept and that's my slope, here's my equation. Y equals -1x plus 2. All right, so that one was when I worked a little bit backwards. I plotted the points first, and then I used the line to write the equation, which just makes life a little easier. I also could have, by the way, in number 3, I could have taken the time to find the slope with the slope formula, you know, y minus y, x minus x, find the slope from there, plug it in, find the b, and then rewrite the equation that way. But since I had the line right in front of me, I might as well go ahead and use it to my advantage to write that equation. Okay, so let's take a look at number 4. Now I'm going to solve for y in this question. I don't have y by itself, so that is not helpful. I need to subtract the 4x, get rid of that whole x term. I need that whole thing to go away. So I'd be left with 2y is equal to -4x plus 8. Then the next thing I would do is I would divide both sides by 2 to again get that y by itself. Every single term gets divided by 2, the whole thing. So those are going to cancel out, which is my goal. That's what I want. I get y by itself. -4 divided by 2 is -2. And then 8 divided by 2 is 4. So I have y equals -2x plus 4. And there we go. Now let's go ahead and put that on our coordinate plane. Here's my y-intercept. Here's my slope. Anytime slope doesn't have a denominator, that's just -2 over 1. So we'll talk about how we graph that. Okay, so start with the y-intercept. My y-intercept is +4. So I'm going to go up 1, 2, 3, 4, and there I am. Then I need to graph that slope. So I go down 2, right 1, down 2, right 1, down 2, right 1. And again, that slope is rise over 1, so it's a -2, but I'm always moving to the right unless I'm working backwards. Like, for example, right now, I could go up 2 and left 1, but I went backwards from the negative slope. So connect those points with a line, and there's your graph. All right, moving on, next one. Let's take a look at this example, number 5. I have y minus 3 is equal to 2 times the quantity of x plus 2. And again, I don't have the graph in slope-intercept form. I don't have y by itself yet. I have to start by doing that distribution. So that's going to give me y minus 3 is equal to 2x plus 2. And then I'm going to go ahead and add 3 to both sides. That's going to make those go away. So I end up with y equals 2x plus 5. There's my equation. Here's my y-intercept. Here's my slope. So again, slope is 2 over 1 if I'm thinking rise over run. Sorry, that was an ugly one. Try that again. Okay, so I'm going to put my y-intercept on the graph first. My y-intercept is +5. So I come up here to positive 5 and put a point, because again, that y-intercept is where x is equal to 0. So I stay on the y-axis, I haven't moved left or right at all, and I go up to 5. Okay, now my slope is 2. So you're probably thinking, hey, I'm out of room on my coordinate plane. You could go up 2 to the 7, which is off the coordinate plane, and over 1, but that doesn't really get you very far. So here's where working backwards is going to be really helpful. If I want to work backwards from this point, that means I would go down 2 and left 1. And you can see that they still fall in the line of what you have. So go down to left 1, down to left 1, down to left 1. And again, I'm just working backwards because I ran out of space in my coordinate plane in that positive direction. So I work backwards, go down in the negative direction. There's my line. All right, next one in number 6. Hey, guess what? We've got an equation in slope-intercept form. Woohoo! So I don't really have to do any work here. There's my y-intercept. And here's my slope. Sweet. So go ahead and graph it. My y-intercept is -6. I'm going to start at the 0 and come all the way down to -6, graph a point. Then the slope is 1/4. So up 1 over 1, 2, 3, 4. Ooh, this is one where we don't have a whole lot of space. If I went up 1 and over 1, 2, 3, 4, I'm like way out here. So you really only have 2 quality points there to connect. 3 if you go off the coordinate plane a little bit. Your line's way down there at the bottom of it, but that's okay. Okay, a couple more examples here. Y equals -1/4 x plus 6. So now, I'm in slope-intercept form, so yay. Here's my y-intercept. Here's my slope. This line looks very similar to the line we just graphed, except that your slope is negative and your y-intercept is positive. So from 0, 0, I'm going to go up to +6, and I'm going to go down 1 and over 1, 2, 3, 4. And again, I'm still out of space. Go down 1 over 1, 2. I'd be out here and then about there. So there's only 2 points on the coordinate plane, but then you get a third one from going off the coordinate plane a little bit, and there's that line. You can see how that line with a positive y-intercept and a negative slope looks just a little bit different than the one we had on the previous slide, which was down here and looked kind of like that, okay? All right, this was from number 6 on the previous slide. Let's take a look at number 8. I have 6x minus 3y is equal to -12. So this one's not in slope-intercept form, so let's take care of that first. That whole 6x term needs to move over. So that's going to go away. Don't lose that negative there. So you've got a -3y is equal to -6x minus 12. Okay, then the next thing I would do is divide everything by -3. That gets divided by -3, that gets divided by -3, and that gets divided by -3. So this turns into a positive y equals, this turns into a positive 2. So I've got 2x, and then that turns into a positive 4. 2x plus 4 is my line there. -12 divided by -3 is 4. -6 divided by -3 is 2. So here's your y-intercept. Here's your slope. Again, that's 2 over 1. Why do I always write extra letters with that? Sorry. 2 over 1. And then here, let's go ahead and graph it. So my y-intercept is positive 4. I'm up here at the positive 4. My slope is 2 over 1. So that's up 2 over 1. And I'm already out of space, so I'm going to go down and back. Down 2 and back 1. Down 2, back 1. Down 2, back 1. And there you have it. I like to go all the way across the coordinate plane. It just helps me draw a more accurate line when I'm connecting those points. And it's going to be really beneficial for you to graph that line all the way across. Sorry, that was a rogue extra purple mark. Okay. We got 2 more examples here, and then we're going to be all done. Hey, let's check out number 9. What's cool about number 9 is we already have the slope and we have a point. So I'm just going to go ahead, I'm going to start with this point, put that point on the coordinate plane. If I go left 2 and up to 1, 2, 3, 4, 5, that is a point that I know exists. Okay, I'm going to change it. It's a little hard to see on the white. Okay, so that's a point that I know that exists. Now, my slope is 3 over 1. So I would go up 1, 2, 3 and go over 1 and put a point. Or I could go down 1, 2, 3 and back 1. down 1, 2, 3, back 1, and keep going. Down 1, 2, 3, back 1. Okay, that's about as far as I could go. There's my line. Oops. So there's the line that this goes with. Now, we can't really tell what the y-intercept is because it's way up here somewhere. So I am going to go through and actually find the y-intercept so that I can write that equation. Since I know the slope and I know a point, I'm just going to plug all that stuff into slope-intercept form. I'd have 5 equals 3 times negative 2 plus b. And remember, we're solving for that b. That's our question there. So I have 5 is equal to negative 6 plus b. Sorry, my b's and my 6's sometimes look similar. Let's go ahead and add 6 to get rid of that, and I get 11 is equal to b. So that's why we couldn't see that y-intercept, because our coordinate plane only goes up to 6. 11 is way up here somewhere, and that's why we couldn't see it. So now if I take that and plug it in and write my equation, here's my b, here's my slope. I have y equals 3x plus 11, and that's the equation that you see graphed in the blue. Okay, and lucky for you, number 10 happens to be a graph that we just did on the previous slide in number 8, so we already graphed this and we don't need to do it again. So thanks for listening today, and if you have any questions, please let us know, and I will catch you next time.